When an instance of a class is created in C++, the class constructor lets us program exactly the initial state of the object that's created. Let's see how this works. In C++, an automatic default constructor is provided for us if we haven't defined any constructor whatsoever. Every class we've seen so far has a constructor. It has the automatic default constructor. All that this automatic default constructor does is it's going to initialize all of the member variables to their default values. Let's look at some code. Here's the cube class that we saw last week. This class has 3 member functions and a member variable length. There's nothing in this class that's a constructor. Because no constructor is present, we have an automatic default constructor. The automatic default constructor, as we mentioned, initializes all of the variables to their default values. What that means is length will take on its default value. So the default value for a primitive type is largely undefined, so we're not sure what the initial length is going to be. If the private member variable was a class, then the constructor is going to define what its default value is. Let's see how we might define a constructor if we wanted to just set up the default values instead of accepting the system default values. To explain what's going on, we want to explain exactly the terminology we're talking about. Earlier we talked about an automatic default constructor. Now we're going to talk about a custom default constructor. The term default constructor defines a constructor that takes in no arguments. A custom default constructor is overriding the automatic default constructor that C++ provides for us. So the simplest constructor we can make is this custom default constructor, and it's going to specify the state of the object when it's being constructed. Because it's a default constructor, it's specifying the default state of the object when no arguments are given. We define a custom default constructor by having 3 conditions being true. We have to have a member function that has the same name as the class itself. So in our cube class, the name of the function is going to be cube. The function needs to take 0 parameters, and the function does not have a return type. So the constructor builds the object. It doesn't return anything back to the programmer. If we look at the name of this function, we know the name of the function is cube. It's part of the cube class, and it takes 0 arguments. If we look at how this looks in code, in the header file for cube.h, we see cube is the custom default constructor. Notice that it has no return type. It's not a double. It's not a void. There's absolutely no return type as part of cube.h. On the other side, cube.cpp is going to define the implementation of the cube constructor. Here we have the cube class defining the cube member function. Because it has no return value and it has the name of cube, we know it's a custom default constructor. And here we have the custom default constructor initialize our cube to have an initial length of 1. So effectively, when we create a cube, our cube is going to be a unit cube, where the length of every side of this cube is exactly 1. For our first example here, we can see that we create a cube using the cube class we just defined. Looking at our code, here on line 11 we have our main function. On line 12 we create a cube in stack memory. And on line 13 we're just going to go ahead and see out the volume of the cube. We know that our custom default constructor created a cube that has a side of length 1, so we expect the volume of the cube to be 1. So our expected output is going to be volume 1 when we run this code. Let's check out what happens. Here on the console, I'm going to go into the CPP constructor folder and then go into example 1, running make to build the program, and then running /main to run our program. The output of this program says volume 1. This is exactly what we expected from the code we saw. Awesome. Let's look at doing a little more fancy stuff with constructors. We just talked about a custom default constructor, which had 0 parameters. However, we can also define custom non-default constructors, or just custom constructors, that allow user code to specify arguments to our constructor. For example, we might want the user to specify the length of our cube when they create the cube itself. So here we're going to use the exact same syntax as our custom default constructor, but have additional parameters based on how many arguments we want the user code to pass in. For example, we might have the user pass in its length. Here we have double length being passed in as an argument. Constructors are not unique. Here in this code example, we see that we have a custom default constructor as well as a 1-argument constructor. So a user using our cube class is able to create a cube that has a default value and is also able to create a cube that has a specific length. In our implementation, we see the exact same thing. We see 2 implementations of constructors. Our custom default constructor sets its length to be equal to 1. our one parameter constructor sets the length equal to the length passed in as a parameter. Looking at a second code example, here's another main in example 2. The key difference between the example 1 we saw earlier and the example 2 here is that on line 5, when we declare UIUC cube to be C2, we're calling a custom constructor. This custom constructor is going to be the one parameter constructor. So the C++ language is going to go search through all the constructors and find the constructor that has one parameter and takes in a numeric value. We see that numeric value is 2. Because we're specifying that the initial length of the side of the cube is 2, we expect the volume to output to be 2 cubed, or 8. So volume 8 is our expected output. Let's see what happens when we run this code. Navigating back to the base directory and moving into example 2, I'm going to run make and run /main. And what we see as the output is the volume is 8, exactly what we expected. Awesome. Let's talk about one important detail before we wrap this up. We started off by talking about the automatic default constructor, the idea that every class in C++ has a constructor of some sort. If any constructor is defined, we don't get an automatic default constructor provided for us by C++. So if we define even a single constructor, the automatic constructor is not provided for us. Even if we define a custom 3-parameter constructor, the automatic default constructor is not going to be provided. So any constructor at all being defined prevents the automatic default constructor from being defined. We're going to see this trend happen throughout all of the different pieces of the constructor that we're going to see throughout the videos this week. Let's look at one example of where this comes into play. So thinking about a combination of our 2 different programs we've seen so far, here in example 3, we have a UIUC cube C being defined on line 12. Let's look at the cube.h class that's here in the example 3 folder. Here we see that on line 13, the only constructor we have is a 1-parameter constructor. Because we only have our 1-parameter constructor, we know that there is no automatic default constructor. And in fact, there's no default constructor whatsoever. There's no 0-parameter constructor. So in line 12, when we're trying to call this 0-parameter constructor, it's not going to find anything to call it. And because C++ is a strongly typed language, it's going to find this error at compile time. So let's see what the compiler says when we try and run a program where we don't have a constructor that's valid for it to run. Going back directory, going to example 3, and running make, we see that we get in a compiler exactly what we expect. In main.cpp on line 12, we have a fatal error where there's no matching constructor for the initialization of the cube. We know there's no matching constructor because there is no automatic default constructor. The compiler helps us out a little bit. It did find a constructor, said candidate constructor is not viable. So it looked at our 1-parameter constructor, and it said the cube with double length doesn't work because it requires a single argument length, but no arguments were specified here in UIUC cube C. The implicit copy constructor and the implicit move constructor are automatic constructors that were built for us, but they also don't fit the bill. So because we defined a constructor and the constructor was not a 0-parameter constructor, there was no default constructor, so there was no way for us to construct this cube. C++ gives us an error when we try and compile this, so you may see this error when you program. It's quite lengthy in length, but it tells us really useful information. So that's C++ constructors, and now you know how to set up the initial value of a class. In almost every class we build, we're going to define a constructor so that we can have control of exactly what the initial state of the class is. So we'll see a lot of these. In the next video, we're going to talk about another form of constructor that helps us copy an instance of the object to another instance. I'll see you then.